Hi everyone, in this video we're going to be talking about two formulas, the distance and midpoint formulas. Before we get started, we're going to talk about graphing. So our objectives are to use the two formulas, but first let's talk about our rectangular coordinate system, which is where we're going to graph our points. So we begin with two real number lines, and one of them's horizontal and the other one's vertical. And then they have different names, so this might all be familiar. If not, that's okay. This is the horizontal axis, which is called the x-axis, and then this one here is the vertical axis, called the y-axis. And so we plot our points using these this coordinate system created by these axes, and then that center point right there in the middle, that has its own name. That is the origin. So this point right here is 0, 0 as a coordinate. And so it helps to put tick marks like we have here. You can label them with numbers. You don't always have to label them, but this would be 1, 2, and so on in the positive x direction, and then -1, -2 in the negative x direction. Up is +1, +2, and then down is -1, -2, and so on. So our coordinate system has a few different names. It's called the rectangular coordinate system. It's also called the Cartesian Coordinate System, named after the philosopher and mathematician René Descartes. So you might hear it called both of those. You might also hear it called the XY plane. So just be aware, all three of those terms mean the same thing. It's all referencing the same space, the 2D space. That's an x-axis and a y-axis that we plot our points using. So rectangular, Cartesian, or XY plane, all the same thing. And so when we are interested in plotting points in our 2D space, our XY plane, the order matters. Every single time you have a point, the ordered pair is always x first and y second, every single time. So our ordered pairs create these points, also called coordinates. So let's just take a look at a few of these. So how about this point right here? So this point located in our 2D space is located at the point -3, 1, and the -3 is our x value, our x coordinate, and then the y is 1. So notice how we get there. I'm going to draw the path. So we go -3 in the x direction, so that's right here, and then we go +1 in the y direction, so that's right here. And then where these meet, it forms this rectangle, and we meet at this point, which is -3, 1. So this is why we have this rectangular coordinate system. Notice we used a rectangle to get to our point. Let's just pick another one. We'll pick this one down here. So this one is the point 3, -2, because we traveled, let's go ahead and change colors for that, +3 in the x direction, and then down -2 in the y, and then where those 2 points meet is our coordinate. Okay, so that's plotting points or coordinates. So now we have just some names. I usually say x coordinate for our x value here and y coordinate for the y value. But the x-coordinate is also called the abscissa, and then the y-coordinate is also called the ordinate. So just different names. And then our coordinate axes, which are the x and y axes, they actually split this two-dimensional space into 4 parts, and we call those 4 parts quadrants. So real quick, if you're having difficulty understanding this xy plane, or when I say 2D space, just like imagine a piece of paper. That's what 2D space is, two-dimensional space. And so we split into 4 parts, and we go counterclockwise. So when we label them, so we have quadrant 1 right here, and notice here all of the x values are to the right of the origin, so +x, and then all of the y values are above the origin, so +y. Every coordinate in quadrant 1 has a +x and a +y. So if you want to look at it as an ordered pair, your x is positive, so positive x number, and then your y is also positive. And then let's move to quadrant 2, going counterclockwise. Quadrant 2 over here notice what changed. You're now on the left of 0, 0. You're on the left of the origin, so x is now negative, but you're still up above the origin, so your y is still positive. So every point over here, every coordinate, the x value is going to be negative, and the y value is going to be positive. Okay, let's keep going counterclockwise. Next is quadrant 3 down here. And in quadrant 3, you are still to the left of the origin, so x is still negative, and now you're below the origin on the y, so you have a negative y as well. So all the points over here are negative in both numbers, so negative x's and negative y's. So for example, a point like negative 10, comma negative 10 would be over here in quadrant 3 when you graph it. And then our fourth and final quadrant over here, notice we moved to the right of the origin in the x direction, so x is positive again, but we're still down below the origin in the y direction, so our points would have a positive x number and a negative y number. So that might be like 1 comma negative 1. That would be a point in quadrant 4. Okay, so there's our 4 quadrants, and just recognizing what points would be where. You don't have to memorize where the points are, like, oh, in quadrant 3 everything's negative. You'll get very familiar with it just by plotting points. The more practice you get from this, you won't have to memorize it, you'll just start to see it. So now we are ready to find the distance between 2 points. Okay, so I'm going to give you the distance formula in just a minute, but before I do, we're going to kind of derive it, kind of come up with it, because if you know where it came from, it's a lot easier to figure it out in the future, how to use it. So we want to know how far apart are these points. So what we want to do first is plot them on our xy plane, our coordinate system. So notice the first point, x is 0, y is 2. So we don't go left or right on the x-axis because it's 0, but we do go up 2 in the y direction. So that's that point right there. And then our second point, x is 4 and y is 5. We're going to go 4 in the x direction and up 5 in the y direction, and then plot that point right here. And again, the question is, how far apart are these points? What is the distance? In this case, that pink line. Now, if I was using, like, let's say graphing paper and a ruler, I could measure this, just making sure that everything was kind of lined up. That's why I mentioned graphing paper. But it's hard to be accurate doing it by hand, so we're actually going to just do it mathematically. Okay, so to find this length that we're looking for, notice what we're going to do. We're going to create a right triangle. And the reason we're going to do this is because a familiar theorem is going to help us out here. You might remember learning this in the past. We're going to use the Pythagorean Theorem. Okay, so notice what we get when we form this right triangle. We have that from this point to this point here, that's 4 units. Now we can count because this is a pretty small triangle. But let's say this is a really big triangle. The fast way to get the fact that this is 4 units, whoops, is to just take the difference between the x coordinates. So notice that this point here, x is 4, this point here, x is 0. So 4 minus 0, that distance is 4. Again, we just counted on the last slide that this was 4 units, but if this was a really big triangle, that would be pretty tedious to count. So the faster way is to use the coordinates. So let's see, this is 3 units, 1, 2, 3, but let's say I didn't want to count it. I would look at my y values. I would say this y is 5, this y is 2, 5 minus 2, well, that length must be 3. Okay, so now I have the lengths of the sides of the triangle, and if you remember the Pythagorean Theorem from somewhere in your past, if you don't, that's okay, I'll remind you. But if you remember, if you take the 2 sides and square them and add them, you get the long side squared, or the hypotenuse. Okay, so the Pythagorean Theorem, if you learned it like this, you might have learned that a squared plus b squared equals c squared. We're just using the letter d for distance. Another way to remember the theorem is that the hypotenuse squared is just the two legs squared and added together. Alright, so we had a leg that's 4 units, another leg was 3 units. Square those. 16 plus 9, add them. You get 25. But 25 is not the length that we're looking for. Notice that something's not completed yet. This is the distance squared. So we want to go one more step, and we want to take the square root of that number. So let's erase this. And that's going to give us the distance that we want. So that's 5 units. Okay, so we got our final answer, 5 units. Now, again, if you did this on paper by hand and you were making sure you're accurate with your measurements, like let's say that this side was 4 inches, you can measure that with a ruler, and let's say this side was 3 inches, then your ruler, if you lay it across here, you would find out that this would show you that the ruler says this is 5 inches. But we did it accurately using math, okay? So the Pythagorean theorem leads us right into this distance formula that we're going to be learning today. So this is one of the things that you want to remember. You want to remember your distance formula. And why I went through deriving it with you is because it's kind of a lot to memorize without knowing where it came from. So let's say I started the video with just this part here. If I said, hey everybody, here's a distance formula. It looks like a lot of letters and symbols. But if you recognize that this is just from the Pythagorean theorem, this right here is the distance between the x numbers. So let me just write that here. Distance between the two x values. So between x, we'll say x's. And then this one here was just the distance between the two y numbers. And from the Pythagorean theorem, that's like A and B. Okay, so the distance between the x's, quantity squared, notice there's a square up there, so squared, and then distance between the y's, quantity squared, and then you add them. Notice there's a plus sign in the middle. And so normally with the Pythagorean theorem that would equal the long side squared. But we don't want the long side squared because we want just the length of that longest side. So what we do is we take the square root of both sides. And if you square root something squared right here, it undoes itself, and that's just c. So the whole point, once again, I showed you the Pythagorean theorem because it leads right into this distance formula, and it helps you remember this formula. So now it has a little bit more meaning, and hopefully it's not just something super random. You're like, oh, look at all these letters and numbers. So this is your distance formula, this right here. So this is what you want to remember. And we'll go ahead and use an example using this formula, now that we know it. Okay, so find the distance between these 2 points. And so what I recommend, every time I use these formulas, I like to label my x1, my first point, and my y1, and my second point, x2 and y2, because that way later on in my work, I don't get confused or lose track of what was what. And so this is x2 and y2. You don't have to do that, but I highly recommend it. You'll because I see a lot of people make mistakes in their work just by switching or mixing up which points are what. So I'm going to say that my first point is x1, y1, my second point is x2, y2. And so notice in my formula, this right here is x2 minus x1. And then over here, this is y2 minus y1. I just took those numbers and plugged them in. So right here, let's just point to them really quick, just so you know what I'm talking about. x2 was this x right here, minus x1, which is this one here. And then y2 was here, minus y1, which was here. Okay? And then all those are getting squared, and then we add the results. So then we simplify, and we get 5 squared plus negative 2 squared. Make sure you're squaring that negative sign because it's in the parentheses. So negative 2 times negative 2 is positive 4. And then add that to 25. The answer, the distance, is exactly square root 29, but most people don't know like what that number is with meaning. Like if someone says you how far is these 2 points, how far are they apart? Oh, they're square root 29. It means a little bit more if you give them an estimate using a calculator. So this is approximately 5.39 units. So how far apart are these points? Approximately 5.39 units. But the exact answer is the square root 29. So anytime you're asked for an exact answer, don't get the estimated answer from the calculator. But if you do need to approximate or estimate for some reason, use the calculator and get this approximate answer. All right, so that's our distance formula. So let's try another example now. We're going to use our skills that we just learned and consider these 3 points to start with, and then answer a few things about them. So first, let's plot the points and form a triangle with them. And then we're going to find the length of each side of the triangle. So that's going to be 3 lengths we're finding. And then verify that it is in fact a right triangle. So it might look like one when we draw it, but we have to verify it mathematically. We can't just base it off our drawing. And then we're going to find the area of the triangle. So just looking at our 4 things we're finding, this one here, part B, is where we're going to use our distance formula. The length of the sides of a triangle is in fact their distance between the points. So that's the distance formula right there. Okay, so here is our drawing. Okay, I just jumped right to it, but we plotted the 3 points. So notice we go -3 and up 1 for A. Okay, and then B, we go -3. Let's change colors really quick. -3 up 4, and that's B. Okay, and then our last point, +4, and then up 1 is our point C. All right, so we plot those 3 points, excuse me, and then we just connect all the sides to the points, and then that's our triangle. It looks like a right triangle, but we have to verify it mathematically. We can't just say, oh yeah, because it looks like it is. So we have our drawing there. Now we're going to find the lengths using the distance formula. Okay, so from each point. So notice this notation. This means over here the distance between point A and point B. So what you do, and let me write this down, is we're going to just plug right into our formula. So as a reminder, we had A was -3, 1. That's a positive 1. B was -3, 4. And C was 4, 1. Alright, so finding the distance between A and B, let me color coordinate some of this for you so you see it more clearly. This is x2 minus x1. So x2 is technically this one here, minus x1, we'll go green with that, which is this one here. So -3 minus -3. And then y2 minus y1, so y2 is 4, and then minus y1 is 1, so 4 minus 1. Okay, so the 2 point like 1 and 2. Simplifying that, so -3 minus -3 is 0, so 0 squared is 0. 4 minus 1 is 3, and that's going to be squared is 9, so square root is 3. So that's one of the side lengths of our triangle, 3 units. Okay, so we're going to just repeat that process for the other 2 points. So repeating for point B and C. Okay, so let me just color coordinate this for you real quick. So we'll say that C is the points, like our second point, so x2, y2. So notice this is x2 from C, and this is y2 from C, minus from B, x1 and y1. So x1 is here, y1 is here. And then simplify that. This is going to be 7 squared, which is 49, and then negative 3 squared, which is 9. So I know I said it, but if you want to write that down, this becomes 7. This becomes negative 3, but you square the negative sign. That's square root 58 total. So that's not a perfect square. And so that's our exact answer for that distance between those points. And then our last 2 points, same process. Between points A and C, we just fill in x1 and x2, y2 and y1, and then we get 7 for that distance. So those are the 3 distances or lengths of our sides of our triangle using our distance formula. So we actually use the formula 1, 2, 3 different times. So we're getting really good at this formula. Okay, so now we're on to part C. And if you remember what part C asked, it said, is this really going to be a right triangle? So this is a bit wordy, but basically what it says is if you have a right triangle, we know that one leg squared plus the other leg squared equals the hypotenuse squared. I'll write it out this time. Hypotenuse squared. And if you aren't sure which ones are legs, they're the shorter two. The hypotenuse is always the longest, every time. So if this equal sign, pretty much if this equal sign stays valid, like if we don't have to cross it out because they're not equal, then this is a right triangle. Okay, so we're going to use our results from our parts that we just worked on. So if you remember, the distance between point A and point B was 3, and then the distance between points A and C was 7, and then the length of the longest side was square root 58. Okay, so using our Pythagorean theorem, we're wondering, is this leg squared plus this leg squared equal to the hypotenuse squared? And so we have it here. This is 9 plus 49, which is 58. So when you square right here, you square away that radical sign, and it is in fact equal. So yes, it looked like a right triangle, but now we verified mathematically this was a right triangle. And now the last question asked, what is the area of this triangle? And so if you remember from geometry, and you don't necessarily have to have this memorized, but you might this might look familiar, the area of a right triangle is 1/2 base times height. So now that we know there's a right triangle, we can use this formula. Again, this is something you might remember from the past, but if not, that's okay. We have it written here. So we just fill in our values. So either leg can be the base, either leg can be the height. But I'm just going to say the base was 3, the height was 7. So that times 1/2, and we have 21 halves square units, or 10.5 square units. And since it's area, that's why our units are squared. So let's say it was inches, we would say square inches. Alright, the last thing is our second formula that we mentioned when we started, the midpoint formula. So everything we just did was for the distance formula. Now our last formula to learn here in this section is the midpoint formula. It's a formula that's exactly what it sounds like. It gives you the midpoint, the point in the middle of 2 points. So let's say I have a point here, and I have another point here, and we just worked on this distance right now. We worked on finding that. And so what this midpoint formula is doing is it's saying, well, what is the exact point in the middle here? So that is what the formula is giving you. What's the middle between the 2 points that we know? And so notice what this formula gives you. I want you just to recognize the setup on this formula right away. The formula is giving you a point. Okay, so M, standing for midpoint, is an x comma y. So this equals this whole thing right here. I'm going to circle it. This is your x coordinate, and then this whole thing right here is your y coordinate. So this is x comma y. And so when you're done using the midpoint formula, your answer is an ordered pair. It's an x comma y every single time. the distance formula we just used, the answer was a distance. It was one number. The midpoint formula, the answer is an x, comma, y. Okay, so find the midpoint of the line segment from -4 to 4, that's the first point, to 4, 2. And then plot the points and the midpoint. So what we can do with our final answer is make sure that it looks like it's halfway between our 2 points. Alright, so we're going to label. So again, this is something that I highly recommend so that you stay organized. So I'll call this x1 and this y1. And then my second point, I'll label them as x2 and y2. If you get into the habit of labeling, then you won't mess up like on little things where you knew the work, you knew the formula, but you accidentally plugged something in wrong. Okay, so then we can plug right into our formula. Remember, this was from our previous slide. This is the midpoint formula. This is x. So x was, this is what I had circled. X was the first x plus the second x divided by 2. So for us, that's -4 plus +4 divided by 2, which is 0 divided by 2, which is 0. So far, our midpoint, we know that the x number is 0. So next we just have to find y. And so then our y value, this is what we circled on the previous slide, y1 plus y2 divided by 2. So that's 4 plus 2 divided by 2. So that's 6 over 2, which is 3. So now we have our midpoint. This is 0, 3. Before we finish this up, I want to just have some meaning behind this. So from this formula, if you've learned anything about averages in the past, this is just the average of the x's and the y's. So real quick example, if I said, hey everybody, what's the average age of everyone in the classroom? What I would do is I would take all of your ages and I would add them up, and then I would divide by how many students were in the class. So let's say there was 20 people. I would take all the ages, add them up, divide by 20. So what you're doing here, and again this is just to show you where the formula comes from, you're taking the 2 x's and the 2 y's, you're adding them up and dividing by the fact that there was 2 of them. So you're just taking the average of the x's and the average of the y's. That's where that formula comes from. Okay, so the midpoint is 0, 3. And then notice, this is good news, that it looks like it's in the middle. So when we plot -4, 4, so we go over to -4, we go up to 4, we plot that point, and then we plot the point 4, 2, then our midpoint should look like it's halfway in between. And based on the midpoint that we solved for, 0, 3, 0, 3, yes, it looks halfway in between. So let's say we did our work mathematically and then our midpoint looked like it was like over here, we know right away something was wrong. So that's just a nice check to let us know, hey, we got it right. Okay, so that is it for this video. We learned 2 pretty important formulas, the distance between 2 points and the midpoint between 2 points. Okay, thanks for watching.